Imagine someone mastering trigonometry by the age of 13, solving infinite series by the age of 14, and inventing new ways to solve higher order equations by the age of 15. All of this without any formal training in mathematics. That someone was none other than S. Ramanujan, the man who knew infinity. In his short life of just 32 years, Ramanujan changed the course of mathematics. But the man had his own share of struggle. Ramanujan was born in Madras, British India, to a very humble family. His father was a clerk in a shop and his mother, a housewife who sang at a local temple. At an early age, Ramanujan showed signs of his mathematical genius, but he struggled a lot at other subjects, often failing in them. When he was 11 years old, he was gifted a book on trigonometry. Ramanujan mastered trigonometry in just 2 years, but the book that really changed his life was the one that contained 5,000 theorems, which he studied in detail. By 16, he was developing his own theorems. Back in 1900s, mathematics was not an option to make a living in India. He showed his work to many foreign mathematicians, but all of them said that Ramanujan was unconventional and lacked a formal education. But when his work came across the desk of G.H. Hardy in England, the latter could not believe his eyes. Hardy decided to call Ramanujan to England. Hardy, along with his colleague Littlewood, further examined Ramanujan's work, after which Littlewood said, "I think we can compare him with the great German mathematician Jacobi." In England, Ramanujan made a great progress working with Hardy and Littlewood. Ramanujan was exceptionally good at infinite series. Before him, there was an infinite series for pi. The problem was that it was very slow. It took 600 terms to come to the value of 3.14. Ramanujan, on the other hand, developed a series that would converge to 3.141592 just after one term. After spending time with him, Littlewood told Hardy, "Forget Jacobi, we can compare him with Newton." Another famous incident that shows Ramanujan's genius was when Hardy once came to meet him. When he got there, he told Ramanujan that the cab's number 1729 was rather a dull one. Ramanujan said, "No, it is a very interesting number. It is the smallest number expressible as a sum of two cubes in two different ways. 1 cube plus 12 cube and 9 cube plus 10 cube. This number is now known as the Hardy-Ramanujan number." The best incident that is noteworthy is when Hardy came up with a scale of mathematical ability that went from 0 to 100. He put himself at 25. David Hilbert, a great mathematician, was at 80. Ramanujan was at 100.
Yeah. Welcome dear students. This video is on modulus inequalities and its properties. First, let us discuss the properties of modulus inequalities, and we do different problems based on these modulus inequalities. Now we have the properties of these modulus inequalities. The first one, the definition of the modulus inequality, that is mod x is equal to x if x is greater than or equal to 0. That means if x is positive or 0, we are taking it as same x. We know that already. And if x is less than 0, then we are taking it as minus of x. That's why it is converted into positive. Even if you take x is equal to, for example, minus 6, then modulus of minus 6 is equal to minus of minus 6. That becomes 6. Like this first definition is defined. Now the second one is nothing but modulus of x is defined its distance in the real number line from origin to minus x and x. See here, the distance between 0 and minus x, the distance is always positive. That's why it will give you a modulus of x will give you a positive number. And also the distance between 0 and x, this is also will give you a positive number. Therefore modulus of x will always gives a positive number. This distance from origin to two different real numbers minus x and x will replicate the definition of this first one we have here. Now the third one, the property what you have is modulus of a into b is equal to modulus of a into modulus of b, right? This is very simple. You can take any numbers and you can check, right? Fourth one, in the same way, we have modulus of a by b is equal to modulus of a by modulus of b, where b is not equal to 0. Then if b is 0, then it will not be defined. That's why b will not be equal to 0, like this, right? Now fifth one, you have modulus of a plus modulus of b greater than or equal to modulus of a plus b. It's one of the important and a nice property. Okay, the fifth one, example, if you take a equal to 7 and b equal to minus 5, then you have modulus of 7 plus modulus of minus 5 is greater than or equal to 7 minus 5. That means 7 plus 5 is greater than or equal to 2. That is obviously true. In the same way, if we generalize the fifth one, we will get the result. You see, modulus of a1 plus modulus of a2 plus modulus of a3 plus so on up to modulus of an is greater than or equal to modulus of a1 plus a2 plus a3 so on up to an. That is also obviously true, my dear students. Okay, fine. And now we have the seventh property, that is modulus of modulus a minus modulus b is lesser than or equal to a minus b. That is also obviously true. You can check with any numbers, like you can check with any numbers. If you take here, for example, a has some 5, b has some 7, then you know that, right? Okay, you have here, suppose if you take here b as minus 7, like this, then you have the left hand side modulus of a, that is 5 minus of modulus of minus 7 you have here, that is lesser than or equal to modulus of 5 minus of minus 7, that is nothing but modulus of 12. And you have here, from this you have got modulus of 5 minus 7, modulus of 5 minus 7, that is lesser than or equal to 12. That is true. That means you have got 2 is lesser than or equal to 12. That is true, right? 2 is lesser than or equal to 12. That is true, right? See, my dear student, this eighth property, modulus of a is equal to modulus of b, that implies a plus b into a minus b equal to 0. This is one of the nice property we are going to use frequently in modulus inequalities problems. This is now modulus of a equal to modulus of b, that implies, you know, that plus or minus a equal to plus or minus b, right? Plus or minus a equal to plus or minus b. That means you can write this also, a is equal to plus or minus b. That means a plus b into a minus b, if you bring that to the left side, okay, a plus b into a minus b equal to 0, we can write this property, right? This is one of the very important property that we will be using in our problems. Now the ninth property, you have modulus of a greater than modulus of b. By the implication of the eighth property, you can say that easily that a plus b into a minus b is greater than 0. By same method, if you follow that, we will get a plus b into a minus b will be greater than 0. Now the 10th one, in the same way, modulus of a less than modulus of b, that implies a plus b into a minus b is less than 0, right? Like this we will be having. Even suppose if you have equal to symbol here also, like if we have equal symbol, then equal to symbol also will be replaced like this. Okay, modulus of a greater than equal to modulus of b, that means a plus b into a minus b greater than equal to 0. And modulus of a lesser than equal to modulus of b means a plus b into a minus b is lesser than or equal to 0. This is quite true and it is very much useful. We are going to do certain problems based on that. You please observe, my dear students. Okay, welcome dear students. Modulus of A plus modulus of B, the 11th property. Modulus of A plus modulus of B equal to modulus of A plus B. That implies A into B is greater than or equal to 0. That means A and B will have same sign. This result is true only when A and B will have same sign, then only it is true, right? We can check that very simple way. If you take for example A equal to 5, B equal to 7, then modulus of A, okay, you are having here the, right, you have here now the left hand side. The left hand side is equal to modulus of 5 plus modulus of 7, that is 5 plus 7, that is 12, right? And the right hand side is equal to modulus of 5 plus 7, that equal to 12, right? And left hand side is equal to right hand side you have. That means 5 and 7 both are same sign, then only it is true. The same way, if you have A is equal to minus 5, B equal to minus 7, like this, right? And here also you have here modulus of minus 5 plus modulus of minus 7 is equal to modulus of 5 plus of modulus of minus 7. This is now 5 plus 7 is equal to modulus of minus 12, that is 12. That is 12 is equal to 12. This is true when they have both same sign, like A and B. When they have both same sign, then it is true, right? My dear students, like this, this 11th property will be, okay, understood. Now this 12th property, modulus of A plus modulus of B greater than modulus of A plus B. That implies A into B is less than 0. That means A and B will have opposite sign, right? That's why A into B is less than 0 we have got here. We can even check this with some numbers. If you take A equal to 5 and they have some different numbers, A, B is minus 7, right? Then you will have the left hand side is equal to modulus of 5 plus modulus of minus 7, that is 5 plus 7, that is 12 you have here like this. Now the right hand side part, modulus of A plus B, that is 5 plus of minus 7, modulus of minus 2, that is 2. Therefore here 12 is greater than 2, right? 12 is greater than 2, this is true. That implies you have here A into B, A into B. Here 5 into minus 7, that is minus 35 will be less than 0, like this. Minus 35 will be less than 0, like this we have got. Therefore this result modulus of A plus modulus of B greater than modulus of A plus B, right? This result is true only when A and B will have different signs, opposite signs, then A into B is less than 0. That can be easily understood by this illustrative example, right? Now this 13th property, modulus of A plus modulus of B equal to modulus of A minus B, right? This will be true only when A and B, A into B lesser than or equal to 0. That means A and B have opposite signs. A and B will have opposite signs. That we can easily understand by taking the numbers A is 5 and B equal to minus 7. Left hand side you take modulus 5 plus modulus of minus 7, that equal to 5 plus 7, that is 12. Now the right hand side is 5 minus of minus 7, that is modulus of 5 plus 7, that equal to 12, right? And you have got left hand side equal to right hand side. This is possible only when 5 into minus 7 is minus 35 is lesser than or equal to 0. And we are going to use these all problems very nicely, and you can observe these things. 14th property, modulus of A plus modulus of B greater than modulus of A minus B. This is true only when A into B is positive, right? A into B is positive. You can have greater than or equal to 0. That means A and B should have same sign. Let us illustrate with some nice example. You take A equal to 5, B equal to 7. The left hand side you have modulus of 5 plus modulus of 7, that equal to 5 plus 7, that is 12. Right hand side you have modulus of 5 minus 7, that is modulus of minus 2, that is 2, right? That means left hand side you have got 12 and the right hand side you got 2. Left hand side is greater than right hand side because 12 is greater than 2. and that implies A into B. You have 5 into 7, 5 into 7, that is 35 is greater than 0, my dear students, right? This way you have got modulus of A plus modulus of B greater than modulus of A minus B, that implies AB is positive, right? A and B will have same sign, then only it is true. Now the 15th property we know already, modulus of x is equal to k, that implies x is equal to plus or minus k. That means if you have modulus of x is equal to 5, the input value for x, it will be taking either plus 5 or minus 5. That means modulus of x is equal to 5 means x is equal to plus or minus 5. You can give plus 5 as input such that you can get 5 as output, or you can give minus 5 as input such that you will get the output as 5. And modulus of x is less than k, the 16th one, then the result is minus k less than x less than k, right? And that means modulus of x is less than 5 means minus 5 less than x less than 5. And the 17th one, modulus of x greater than k means, right, this is what you will have x belongs to that means x is less than minus k or x is greater than k. That means x belongs to minus infinity comma minus k union k to infinity, right? And this also can be written as minus k greater than x greater than k. That means if modulus of x is greater than 5, you can write as minus 5 greater than x greater than 5. And of course this is, we can write even x belongs to the 16th one, open interval minus k comma k. We can write like this, right? Fine. This is the thing we have here. The same thing if you replace, suppose, right, if you replace, okay, this is like 16th, okay, this we will replace as like 18th one, right? Okay, fine. What my intention is to do here, suppose if we have these things like if we replace, this is now by equal symbol, then we will have equal symbols like this, and this will become now closed interval. Instead of open interval, you will have closed interval like this, and that means x belongs to closed interval minus 5 comma 5 like this you have. And the 19th one in the same way, if you include equal symbol, right, you will be, and here minus infinity is not included and minus k is included, and k is included here. X is lesser than or equal to minus k and x is greater than or equal to k, and here also this is equal to means here it is included and here it is included, and this is also included and this is also included. This way we have these wonderful inequalities properties. Those are very interesting. Now the 20th property, modulus of x whole square is equal to x square, that equal to mod of x square for all x belongs to R. That means, my dear students, if you take x equal to 5, modulus of 5 square, that is 5 square, that equal to modulus of 5 square, that is 25, right? And if you take even minus 5 also, x is equal to minus 5, that means modulus of minus 5 square, that equal to minus 5 whole square, that is modulus of minus 5 square for that modulus, that is 25. And next important property in mathematics, this is very, very important, square root of x square is equal to mod x, that equal to plus or minus x. This you will get by just applying square root to this 20th property. You can easily observe that, right? And also, my dear students, you have got now the 22nd one, modulus of x. This will become modulus of x, right? And also one more thing, 23rd one you have, right, modulus of x is always equal to modulus of minus x for all x belongs to R. These are all very obvious results, because always for this the output value you are going to get it as a positive value. That's why modulus of x is equal to modulus of minus x for all x belongs to R, right? Next, 24th, modulus of x is equal to the maximum of minus x comma x, right? My dear students, you can take, for example, modulus of 5 if you want. You can illustrate this nicely. This is nothing but maximum of minus 5 comma 5, right, like this. And the maximum of minus 5 comma 5 is nothing but 5. Therefore, modulus of 5 is nothing but maximum of this. Suppose even if you take modulus of minus 5, this is nothing but a maximum of minus 5 comma minus 5. That is, right, 5 comma minus 5, and maximum among this is nothing but 5. In any case, however, we have got the maximum. Modulus of x is nothing but maximum of minus x comma x, right? In the same fashion, we have the modulus of minus of modulus of x is nothing but minimum of minus x comma x. The same way we can define, suppose if you have minus of modulus of 5, this is nothing but minimum of modulus minus 5 comma 5, that is minimum is nothing but minus 5. Like this we are going to get even minus of modulus of minus 5, this is nothing but minimum of minus 5 comma minus 5, like this. This is now minimum of right, my dear students, 5 comma minus 5, this is nothing but minus 5. Like this we will define these things. Okay, these are very, very important, please observe. Now the other property, 26th, maximum of a comma b, that is equal to it is defined as a plus b by 2 plus modulus of a minus b by 2, right? Now that is maximum of 2 comma 5. If you take that, that is now 2 plus pi by 2 plus modulus of 2 minus pi by 2. That means 7 by 2 plus 3 by 2, that is 10 by 2, that is 5. Therefore, maximum of 2 comma 5, we have got it as 5. And that 5, how we got it is maximum of a comma b as a plus b by 2 plus modulus of a minus b by 2. In the same fashion, another property 27, minimum of a comma b is defined as a plus b by 2 minus of a minus b by 2. Right? If you take minimum of 2 comma 5 as an example, 2 plus 5 by 2 minus of modulus 2 minus 5 by 2, that gives you 7 by 2 minus 3 by 2, that is 4 by 2, that equal to 2. Therefore, minimum of 2 comma 5 is 2, which is got by minimum of a comma b as a plus b by 2 minus of modulus a minus b by 2. Right? Now let us do certain problems, some basic problems based on the properties what we discussed now. The first problem, modulus of x equal to 8. The solution of the first problem, my dear students, given that modulus of x equal to 8, we told that already modulus of x is equal to k, means x equal to plus or minus k. From that you know that x is equal to plus or minus 8. Right? X is equal to, you will get plus or minus 8. This is what the solution of the first problem. Now the second one, in the same fashion, you have modulus of, we told that modulus of minus x is equal to modulus of x, that is given as 5. That implies x is equal to, you will get plus or minus 5. This way you will get the second problem. Now in the same way, the third problem, you have here modulus of x plus 1 is equal to 5. That means, right, x plus 1 is equal to plus or minus 5. That means x is equal to plus or minus 5 minus 1. That is right. You are going to get, my dear students, this is 5 minus 1 and minus 5 minus 1. That is x is equal to 4 and minus 6. Right? When you take x is equal to 4, 4 plus 1 modulus will give you 5. And when you take x equal to minus 6, that means, you see, modulus of 4 plus 1, that will give you modulus of 5, that is 5. And modulus of this minus 6 plus 1, this equal to modulus of minus 5, that equal to 5. That's why x is equal to 4 comma minus 6. Both are our desired solutions. Right? Now this particular problem, solve modulus of x minus 3 equal to modulus of 2x minus 8. My dear students, we know that we did modulus of x is equal to modulus of y. That implies we did now only x plus y into x minus y is equal to 0, right? By using the same thing, right, my dear students, in the place of x we have x minus 3, and the place of y you have 2x minus 8. That means x minus 3 plus 2x minus 8 into x minus 3 minus 2x plus 8 is equal to 0. Right? Now you have x into 2 plus 2x, that is 3x minus 11 into, you have got here x and minus 2x, that is what, minus x, right? Minus x plus 5 is equal to 0 you have got from this. From this, my dear students, x is equal to 11 by 3 or 5. These are the required and desired solutions you are going to get this particular problem. You can even verify that, back verify, will get the left hand side is equal to right hand side is satisfied for this particular problem. Now regarding this particular problem, fifth one, solve modulus of 2x minus 1 greater than modulus of x plus 2. We know the result whenever we have something like mod x is greater than mod y. We know that x plus y into x minus y greater than 0. By using this particular result, my dear students, we got x plus y. X means 2x minus 1 in the place of it. 2x minus 1 plus x plus 2 into 2x minus 1 minus of x minus 2. Okay, in the place of y you have x plus 2. In the place of x you have 2x minus 1. That means x plus y into x minus y greater than 0. This simplified to 3x plus 1. 2x plus x, 3x plus 1 into x minus 3 greater than 0. And this is a quadratic inequality. You know the solution set for this. The critical points are minus 1 by 3 and 3. Right? And x is less than minus 1 by 3 and x is greater than 3. That means the shaded portion what you have with the open circle, that means x belongs to minus infinity comma minus 1 by 3 union 3 to infinity. This is the solution set that you are going to have for this particular problem, right? Now regarding this particular problem, solve modulus of x plus 1 plus modulus of x plus 2 is equal to modulus of 2x plus 3. By looking this problem, we can easily identify that modulus of a plus modulus of b equal to modulus of a plus b. Here a is x plus 1 and b is x plus 2. That means okay, a plus b will give you x plus 1 plus x plus 2, that gives you 2x plus 3. That means a and b should have same sign. That means a into b should be greater than or equal to 0. Now by adopting this result, we have my dear students, a into b, that is now x plus 1 into x plus 2, that is greater than or equal to 0, like this, right? For this, you know, this is a quadratic expression. Nicely, this is now minus 2 and minus 1, minus infinity to plus infinity you have got here, and this is of course it is included. Now it is included like this, right? And this is also included like this, right? Therefore, we have got x lesser than or equal to minus 2 or x greater than or equal to minus 1. Therefore, x belongs to minus infinity comma minus 2. This is closed interval you have got, union, right? And minus 1 to plus infinity. This is what the solution set that you are going to have for this particular problem. My dear students, you please observe. Now this particular problem, my dear students, modulus of 2x minus 1 plus modulus of x minus 2 is equal to modulus of x plus 1. Right? This is now modulus of a plus modulus of b equal to modulus of a minus b. Right? This inequality is true. We already discussed it when a into b is lesser than or equal to 0. When they have opposite sign, then it is true, this particular result. Therefore, my dear students, here a is 2x minus 1 and b is x minus 2. Therefore, a into b, right? That means 2x minus 1 into x minus 2, that should be lesser than or equal to 0. That means, my dear students, here the critical points are 1 by 2 and 2, and this is minus infinity to plus infinity. Between that and the equal symbol is there, that will be included, and this is what our solution set we have like this. Now x belongs to closed interval 1 by 2 comma 2, right? This is the solution set we are going to get for this particular problem, my dear students. It is one of the very, very important problem which is based on the properties what we have discussed. Directly it follows from the properties, right? Now this particular problem, 8th one, solve modulus of x minus 1 plus modulus of x plus 1 greater than 2 times of mod x. This even you can write it as modulus of 2x, because 2 is a positive number you can bring outside. And see, my dear students, for this problem we are going to use this property of the modulus inequality, modulus of a plus modulus of b greater than modulus of a plus b. That implies a into b is lesser than or equal to 0. That means a and b should have opposite sign, then only this result will be true, right? This is already we have discussed it, right? That means, see my dear students, a into b, we have x minus 1 here, a, and x plus 1, that should be lesser than or equal to 0. That will be lesser than or equal to 0 we have got here, and therefore the solution set for this is minus infinity and this is plus infinity, this is minus 1 and 1. Here these things now included, right? Included, that means in between of that we have, therefore x belongs to closed interval minus 1 comma 1 is what the solution set for this. And of course this is nothing but minus 1 lesser than or equal to x lesser than or equal to 1. These x values are in minus 1 and 1. This is the solution set that you are going to have, my dear student. This next problem, this particular problem, we have ninth one. Solve modulus of 2x minus 1 plus modulus of x minus 2 greater than modulus of x plus 1. Right? We need to get x values in the real number line. For this, my dear students, we are going to use this result. Right? Modulus of a plus modulus of b greater than modulus of a minus b, that means a into b is greater than or equal to 0. Right? When they have the same sign, then only this is true. That means we have in the place of a 2x minus 1 into the place of b you have x minus 2. That is greater than or equal to 0. Therefore, you have got the quadratic inequality, the 1 by 2 and 2 you have, my dear students. This is minus infinity and plus infinity, and this is right. We have here like this and like this, right? You know, when it is greater than or equal to 0, the solution set is like this. That means now x lesser than or equal to 1 by 2 or x greater than or equal to 2. Therefore, my dear students, x belongs to minus infinity comma 1 by 2. This 1 by 2 is included, union 2 to infinity, right? In this way, my dear students, we will do this beautiful problem, right? And dear students, thank you for watching. Please subscribe to the channel Iconic Maths Srihari to get more interesting videos on different topics on mathematics and the content which is related to mathematics. And we are going to get and some other interesting problems on the next video. Thank you very much.